Thank you, Marcus. Thank you for joining me today here, the very last talk of the show. Everybody having a great show? Nice, nice. I hope you all had a cup of coffee just now, so we can all stay awake. I had about 15 of them today. So my opening screen here has the title of the talk. I hope you found a couple of words on there that obviously brought you into this room to come and listen to me. I certainly hope that one of those words is performance. That's really what I'm all about. And the other one, I thought it was really applicable to have the word assert sitting in a stop sign. You know, as functional testers, that's what we do. We assert things, and we check that things are okay. If not, we hopefully stop deployments. Standard functional testing, I'm sure you guys know what I'm referring to there. Combining these two things is really what I want to talk about. But before I go there, I thought, you know, maybe just a little bit about myself. Who is this guy on stage here? My name is Marcel Verkerk. As the last name maybe suggests to some of you is I was born in the Netherlands. I live in the States right now in beautiful Arizona, Phoenix, Arizona. I have about 25 plus years of experience in IT, all kinds of different things, ranging from setting up printers and troubleshooting them to building Novell workstations and installing WordPerfect, all the way to doing ERP software implementations, software testing at some point. I worked about 5 or 6 years for a company called CompuWare, sold QA tools for that company, and also changed my career there to deal with application performance tools. That was a major shift in my career. I've been doing performance ever since. A few things that I'm not. I'm not a tester. I'm not a developer by trade. And I don't use Selenium. Certainly not on a daily basis. And if you guys were here during the assignments keynote, right about now he would ask this question. What the heck are you doing here? Well, I kind of gave it away. My really big work passion is web performance optimization. Web performance optimization has a lot to do with the front end, the end user that's on the receiving end of a web page. And I do that in a performance engineering team, which is really cool to have at a company called GoDaddy. American-based company out of Phoenix, Arizona. Is a pretty big company when it comes to web hosting and domain names and such. As you can see from some of the numbers here, just a huge footprint on the internet in terms of websites hosted, numbers of customers, 71 million domain names registered with GoDaddy. And what that means is that we have to do, for example, DNS for all of those domain names, and that results in about 18 billion DNS queries that run through our network every day. Huge footprint, and all of that has to do with websites, web hosting. So you can imagine that for a company like that, performance is incredibly important, incredibly crucial. If you guys were to choose to host your website with GoDaddy and your website is slow or is perceived to be slow, everybody's going to point not at you but at GoDaddy, right? And we get that all the time. So performance is incredibly important to us. And the company gladly recognized about 10 years ago that we should set up a performance engineering practice in the company. And so I've been working on that for quite some time there, over 9 years, and the stories that I can share are not always, you know, a lot of fun. There was a lot of frustration along the way. And one of those stories, I've managed to capture this blue line, this chart of a particular URL that GoDaddy hosts, and the team behind that built this URL and maintains this URL. And what we saw in production, when we measure and monitor this URL, we use a technique for that that's called real user monitoring, which allows us to grab performance data from all of our users worldwide. Every time they hit this page, there's a little bit of performance data in the browser that I'll go into a little bit more in a second. And that data is sent back to GoDaddy, and we collect all that data and we produce charts like this. And so when we started looking at this page, and this is all production data, right? So this is a page that's live, it's being used by users all over the world. And we started looking at this page, and it turned out that the 75th percentile of the performance of this page was sitting at about 10 to 12 seconds. Which, didn't make us really happy, not angry yet, but it wasn't great. But at some point during the cycle of monitoring, we saw the page load time shoot up to somewhere around 22 seconds. And that made us angry as a performance team. We went to the team, angry/frustrated. Don't think of us as running around as angry people shouting at people all day long. But it certainly made us frustrated. So we would go and talk to the team, sit down, analyze the page, and try to figure out what was it on this page that made it go up to 22 seconds. And then we would find and look at best practices and tell them, maybe you don't want to load this JavaScript this early. You may want to move that down in the page a little bit. And so we would help them improve the page, and, performance would go down again. Still not quite at the level where we wanted to be, but we were back where we were before the spike. And then we'd leave the team alone for a couple of weeks, a couple of months sometimes, and we would look at the data again. And meanwhile, the marketing team had come by and told them to put some other crap on the page. And guess what happened? Performance went up again. And then we'd go talk to the team again and take it off or move it or load this stuff in a smarter way. That was oftentimes the big answer to improving performance, was the way things were loaded in the page that could be changed without affecting what the page looked like. So this went on, and we were going up and down every time. And we realized at some point we can't keep doing this. We're not getting where we want to be. So then we came up with the solution I'm going to talk about today, some automation. We thought about this thing keeps going out to production, and we find the performance going up every time. We need to get in front of this thing. So what better to do than to think about automation and get with the folks that are active before things go to production? Testers, right? And we introduced this automation to them, and wonderful things started happening. We didn't see these spikes anymore. Not only that, the performance got gradually better. And that was a wonderful thing. The team we sat down with every time was so motivated to keep making performance changes because things were getting better. We weren't seeing these crazy spikes anymore. And so we took this chart and we thought, let's go one little step further, because underneath, we as a performance team always knew if we get this chart and we get this significant dive down and the performance improves this much, we know there's something else that's going to happen. Because we know this extremely well. We've seen other studies that have been done by numerous big companies, Walmart, Google. They've all done studies that have shown that web page performance directly correlates to money, to revenue. A faster page generates more revenue. So we actually took a slightly different page from the same team where we had the exact same pattern. And as you can see here, towards where the second red line is. The first red line is where we started working with them. We had this up-down pattern again, and then eventually it made this big dive to areas where we wanted to be. And then we went to the BI team, the business intelligence team that have all the financial data related to this page. And we asked them if they could produce a chart that would show the revenue related to just this page. And that's the green line. And when we put these two together, management just went crazy. Are you kidding me? Right? So performance dropped by, I think we went from around 14 seconds, 16 seconds down to 5, 6-ish. And this is the 75th percentile of all users around the world. Still not really where we want to be. At GoDaddy, we have an SLA of 2 seconds globally. That's a pretty high bar, I can tell you that. But to see performance go down by just over half and revenue go to about 2.5 times what it was in 2014, that was pretty big. So altogether, after this study, and after seeing all this data, what did we really learn is that all the monitoring combined that we were doing was, and that includes server monitoring, CPU, database, stuff in the back end. We were monitoring the snot out of everything at GoDaddy, including this production data that we were getting from our real users. It just wasn't enough. Because measuring in production just simply means that you're always too late. You're always responding to performance issues too late. It's already out in production. So that was a problem. And we realized we got to get in front of this thing. So, we have to stop deployments before they go to production. And that's what I said earlier. We thought immediately about test teams and testers. How can we get together with those guys and try and see what we can do there? And the funny thing is that when you think of test teams and you talk about performance testing, generally the minds go towards load and stress testing, which is a form of performance testing. But for me, load and stress testing is more about the back end and the capacity of the back end and what it can do under load. But we wanted to focus more on the front end, the end user, the integration test when you really test the GUI. What can we do there? Is there anything we can slide into that and make it part of what they already do every day? And so we came up with the solution that we like to just call timings. And that's how it's out there. We just released it last week. So this is really the first time for me to announce publicly that we have the Timings API and 2 clients that go along with this API. We've open sourced it. Literally up to half an hour when I got on the plane in Phoenix last Friday is when the last bit of code went to GitHub. So it's out there for you guys to use. Again, there's really 2 components to this. There's an API, and then there are clients. And I'd like to go a little bit into what that really means, click, and what this solution is all about. So really high level, imagine yourself being the tester on the left upper side with your test script that does functional testing, UI testing. It can even be API testing, where you may not have a script. Maybe you do. I don't know. People test the APIs in many different ways. But the core idea of this solution is to, without getting too much in and bother the tester too much in changing their scripts to do this thing, we came up with an API that's very easy to talk to, especially through the clients that we've built. Is that when the test script does its thing and it spins up the browser via WebDriver, this is where we realize that, wait a minute, when all these testers are spinning up browsers every time they run tests, we know that there's something hiding inside of those browsers that we can get our hands on. And we want these test scripts to send that to the API so that we can go ahead and then store that in this case, we chose Elasticsearch and then Kibana as a presentation layer. If we can capture all that data every time they test for all of the pages that they test, we could build up some fantastic data. And we can do something even cooler, is as in the example of the bottom chart there. When we have all this data, every time the tester runs his test and sends the new performance data to the API can go dig back into the history of that URL, of that page, and tell you where you are. are you over or below your own baseline? You're building up your own trending data, you're building up your own baseline. And you can compare yourself to your baseline every time you test. And so the magic, as I said, is hiding in the browser. And I don't know how many of you know this little mini chart that's there sitting between the test script and the API. I decided to blow it up a little bit because you could absolutely not read that just now. Is anybody familiar with the W3C Performance API? Very, very, very few hands raised there. That's interesting. Every major browser that's out there today, and it's been around for years, has an API built into the browser. It's the Performance API that stores timestamps for all of these events that you see on the screen right now. What you see on the screen right now from left to right is a page load, just the HTML of the page. Because if you load a page from the web, from a web server, it all starts with DNS. You have to do a DNS lookup. You have to make a TCP connection to that web server. Maybe some SSL has to occur. It's an SSL page. You have to do an SSL handshake before you are even allowed to talk to that server. And then finally, where it says request, the box that says request, there's a marker there called the request start. That's where your browser sends the GET request finally to the web server. And then the web server receives that GET request, understands it, and says, hey, I need to go get some data maybe from our backend, and I'm preparing the HTML now. And then the web server starts sending the data back on the network. And that arrives in the browser. The first byte that arrives in the browser is the end of that request box. And that's request end. Now, when you have timestamps on all of these events that occur, you can start calculating, for example, from navigation start to load event start is what we call page load time. But you could also calculate your server's time to first byte, which is a very interesting metric to look at, because that says something about your server, not only your server, but your entire backend behind it, and how long that took to generate that HTML. All of this data is in the browser. You don't have to do anything for that. Anytime you load a page, I challenge you to go in your favorite browser, open up the console, and type this in your console, performance.timing. It will work. You will see those 15 or 16 or so timestamps show up in your browser. And when it's there, you can collect it. So that's what we did, and I would maybe like to show you what that looks like. Yes, that's exactly how I feel right now. I could use a lot of crossed fingers. Live demo, Marcus just told me that there's been a lot of requests to see a little bit more of code, so hopefully I can help with that. There will be a little bit of code in this demo, not a whole lot, but let's see. I'm going to do a few things here, and whoever is furthest in the back, tell me when you can read the screen. Good? All right. So I'm going to do a couple of things. I told you there's two components to this solution. There's the API that's got Elasticsearch and Kibana underneath it. Now, that alone may sound challenging to you. If you would want to run this API back at your company or ask somebody to spin up this API for you, you'd have to tell them to get a box that runs Node and Express. The API is based on Node and Express, and run Elasticsearch somewhere with Kibana. If you already have it, great. If you don't, I've gone a little bit farther and beyond than just building the API and using Elasticsearch. I'm a huge, huge fan of Docker. So what I'm going to show you here is how easy it is to bring up this API, cross your fingers, with Docker Compose. What's happening right now is that Docker Compose is spinning up 3 Docker containers. One is the API. That'll show up in green. I don't know if that's, there it is, timings. Elasticsearch, as well as Kibana. And this literally takes few, probably about 30 seconds, it's already up, by the way. It's that easy to spin up the API. Right, and to show you that it's up, I was refreshing these pages just before I got on stage, and there was nothing there. And so now, it worked. All right, so that's the API with Swagger documents. Super easy for you to just go to the API and start playing with the endpoints. You shouldn't really have to, because you're going to hopefully use the 2 clients that we have, and you don't even have to worry about this. The other component worked. Elasticsearch is up. And last but not least, Kibana. All 3. Nice. Now, if you're at all familiar with Kibana, I love it. I love Elasticsearch and Kibana. The entire Elk stack is absolutely fantastic. We chose Elasticsearch because it is just so great for data analytics. It is incredibly fast in finding stuff. And Kibana is an out-of-the-box presentation layer that's got all kinds of visualizations that you can build, dashboards that you can build. We went one step further, and we don't only just give you this. We also have this little Python script, and I'm hoping to incorporate that into that Docker Compose thing that you saw earlier. But just by running this little script here, and that literally took about 2 seconds, you now have in Kibana. Let's load up the dashboards again. Sorry, I have to put on my old man tools. There's nothing there yet, but this is a complete dashboard with charts and graphs and what have you, out of the box. And I assure you, building things in Kibana can be a little bit challenging. Once you've built the visualizations, you can combine them in the dashboard, you're good to go. But this helps a lot. But as you can see, there's no data yet. So I'm going to go now from being an operations guy who just built an entire API, and I built Elasticsearch, and I built Kibana. I tell my managers that I built that. I didn't. You can just download a Docker image of Kibana and Elasticsearch online and spin it up like that. So, but it gives me kudos. My boss thinks it's cool. Is this the most simple Python test script you've ever seen? Super simple. It's my starting point. And just to kind of make sure that my IDE is working. Very familiar to you guys, I'm sure. Maybe not everybody writes their test scripts in Python, but I just chose it because it's super simple. It looks simple. You just saw the Selenium conf page come by. My script checked for a certain class called section header, made sure it was there, and it was there. And it's really hard to see in the left bottom there. I've got a little printout that says page looks good. If that class had not been there, it would have said page sucks. So I'm glad that that came up. So to go from that simple script to now having essentially the same script. It's a little bit longer. There's some extra code in there. And I made it quite a little bit verbose, more verbose than you would see it. Because really, in essence, there's 3 major lines that you would add to this simple test script in order to work with the API. And so the first line, line 7, is where I've already done this beforehand. I ran pip install timings client. That's all I had to do. As I said, it's out there public. It's in the public PyPy repository. Pip install timings client. And that means, of course, in my script, I have to then import the class called perf from that client. And I'm doing that on line 7. The rest is pretty much the same as the other script. Setting up my Gecko driver, loading the Selenium conf page in there, checking if it's functionally OK. And then I'm going into my performance stuff. Now, in this particular script, I'm using a custom config file. If you don't do that, then the client is going to use a bunch of default parameters that it will send to the API. And to show you just real quick what that kind of looks like. So there's my custom configuration script. There's a couple of interesting things in here already. The API needs to know a few things. A lot of these parameters are completely optional. If you end up using this API with, say, Ruby or Java or .NET, whatever language you use, these parameters may come a little bit more important because you're going to talk directly to the API until we have some clients for those languages to make it easier. But things about the baseline, for example. When I run my tests and I want the API to go look at what the baseline is for this page, right now the default settings are go back 7 days and take the 75th percentile of those 7 days and compare my current performance to that baseline. But you can completely alter that and set it exactly the way you want it. We're also sending a bunch of metadata to the API so that you can slice and dice the data by, for example, by browser or by the environment that you're testing against or testing from. And that's really where then the power of Elasticsearch comes in, that you can slice and dice your data any which way you want. So I'm using this custom script here, and I made it really custom because I'm now a tester that's part of the Selenium team. My test that I'm running here is a demo. So I'm doing that up here. I'm pointing to my custom config file. Then I'm instantiating the perf class with that custom config file. And then this is one of the 3, I would say, important lines in the code. And I'm going to run through these steps a little bit more in detail in a second here. The trick is that I'm going to ask the API for the JavaScript that I need to insert in my WebDriver to grab the performance data. So you don't have to think about the JavaScript you need for that yourself. The API gives you the JavaScript. And then I store that in inject code. Here, by the way, I'm setting a few of the default parameters. I'm overriding them with some stuff that I want to store. And then on line 29 is when we actually do the .execute script to execute that JavaScript in GeckoDriver. That gives you the performance data back from the browser. I'm storing that in this variable called timing. And then I'm going to talk for the API again for the second time. But this time I'm sending the performance data to the API. And then we do a check, and that's the line 32 is really the line that goes back to my opening slide. This is an assert, like any other functional assert you might do in a test script. Because the API comes back with a response, and in there is a field called assert, and that's a boolean, true or false. And if it's false, that tells you that your performance was above the baseline. And you can now take decisions and say, well, if it's false, maybe I'll run my script again to see if it was a fluke. Or maybe I will run it 3 times, and if it's 3 times false, stop the build, something's wrong. That's the idea. So let me run this guy, and then I'm gonna, well, Kibana is already refreshing itself, so I hope you can kind of see that over on the right. Theoretically, and this is still part of the cross your fingers live demo, we got data in Kibana. Right, so as you can see, and this might be hard to see, I have a few blow-up screenshots of this later, but there's one test result in Kibana right now, and it failed. It had a performance of 5.4 seconds just now, and my SLA was 4 seconds. So the page load that you just saw happening, and I'll run a couple more, just for the fun of it. I created a script that'll go in a loop and do this a couple more times. And as you know, when you run WebDriver locally on your machine, you're going to see a browser flash on the screen once in a while. That is if this demo works. Well, there's a test, another test, and you can see that the The charts in Kibana are already changing. I've got 2 tests now, 3 in fact. It's going up. I got 2 passes, 1 fail. If we keep doing this, whether you test once a day or 50 times a day, all this data is stored in Elasticsearch. Your charts are going to start making sense. Your baseline is slowly going to adjust to the performance that you get every time. And it really works. Over on the right, there's a bar chart that shows you your passes versus your fails. And these are passes, fails based on performance. So I won't keep this running because it's really annoying to see the browser flash every time. Looks good so far. Cool. So what we just saw happening was the interaction between the test script and the API. And just to repeat real quick so you get a good idea of how this works. And by the way, there's a reason why I open sourced this, because this is just my idea of how we could do this. I've talked to a few folks this week here at the conference that have had similar ideas, that have tried doing this in different ways. My approach was to make that first call and ask the API for the JavaScript, and then have the tester again, once he gets the performance data from WebDriver, have the test script send that data back to the API. And there have been some discussions about, well, why wouldn't you just let WebDriver talk back to the API? So ideas like that, I would love to share thoughts on that and have people help with this project and contribute and share ideas. My thought was, what if the API is in a place where it cannot be reached by WebDriver because of where WebDriver is running? Could be in a grid, and that grid node cannot reach the API. You know, I thought, as long as the tester can talk to the API, then we've got things under control. But this is essentially the flow. A lot of it happens on the tester side of things, and there's just the API listening for you to communicate to it, and that works really well. And then ultimately, what I think, and this was really the onset of this project, was we wanted to get to this point where we can give a thumbs up or a thumbs down to the tester. Your performance is good or your performance is bad. We could do lots of more things with this thing. The fact that it's storing its data in Elasticsearch and you get this tremendous amount of data, in the future we could even turn this into a production monitoring system. And why not take your test scripts with you to production and run them every 5 minutes against your production system and collect data from the browser every time you do it, right? So there's a lot of stuff we can do. So back to this drawing, the Elastic side of it in Kibana, I just thought I'd blow up a few of the charts that are in our production instance of this API. This is GoDaddy data from one particular team, filtered down to one particular URL, a particular browser. This was actually a mobile browser on a mobile device, and this is the kind of data that they get. This is 1 week's worth of test data for them, performance test data, coming from their functional scripts. And I had to sit down with the guy who builds these scripts, literally for 15 minutes, and we had his script instrumented with this stuff, and he started generating data. And he now gets, you know, the thumbs down, where you see the green line going through the purple line. The purple, it's the bottom purple. I guess it kind of looks more blue. The one that's more steady, kind of going through it all, that's the baseline. And when that green line, the actual measurement, goes through the baseline, he gets a thumbs down. And that team has made a commitment. As a test team and a development team, the product manager is on board, that when that happens, they stop the build. This build will not go to production when this happens. And they have some logic built in. Like I said earlier, they retry the test 3 times and make sure that it was not a fluke. If they see 3 falses coming back from this API, stop the build. And then, you know, what the test manager and the product manager really like is they sit down and look at all of their test results. How many times did we fail performance? How many times did we pass? These are just some examples of there's about 25 visualizations that we give you for Kibana. You can design your own dashboard any which way you want. And more recently, this project's been going on since about end of 2016. Like I said, the first onset was to get the thumbs up, thumbs down, but then we kept on going further and adding stuff to it. And the one thing we're really, really super excited about is when we realized that we can grab performance data from the browser with performance.timing, we also knew that there is another part of that same API. It's still part of the performance API. You can also ask the browser for all of the performance data of all of the resources that were on that page, not just the HTML, the page itself, but all of the resources that were loaded on that page. And when you grab that, you can then build something like this. And this, we call this a waterfall, a page load waterfall. And you can exactly see in time which resources were loaded when, but more importantly, which resources were waiting for other resources to load. And I ran this test, I think it was October 9th, so that was yesterday afternoon. I was testing in the hotel room to make sure that my demo was working. I was capturing the Selenium Conf homepage, and this is what that page looks like in terms of a waterfall. And we can now see that just to get the HTML, we're already 1 second into the page load. That's the very, very first top bar, number 1. You're almost a second in already by the time you just get the HTML. Then the browser starts parsing the HTML. It says, hey, you need to go get some CSS. You need to go get some other stuff, some fonts, some images. And then eventually, the blue line, 3.251 seconds in, to be exact, is the page load time. So if there's anybody from Selenium who built this page, come see me afterwards, because I have some tips. I think that's really cool. It helps us a lot. It helps the test team also to look at when performance is bad, they pull up these waterfalls and they analyze it as a team. They don't even call us in anymore. We've trained them to look at waterfalls. So, I really hope by now that you're thinking this. And I really quick, you don't have to write this down. The slides will be available after the show, so will the video. It is super simple. I showed you the Docker Compose stuff. That's publicly available. You can git clone that. All you have to do is run Docker Compose up and then run the Python script to populate Kibana, and your API is up. And then on the client side as a tester, right now, JavaScript and Python. I really, really wanted to stand here today and say we've got a Ruby client and a Java client and a .NET client as well, and any others that might be out there. But we're not quite there yet. And again, so shout out to anybody who likes this kind of stuff and may want to contribute. I'll take all the help I can get. But for JavaScript and Python, standard install procedures, npm install, safe dev, timings client, JS. And for Python, pip install, timings client. And you should be good to go. The only thing you have to do after this is make a slight change to that config file. If you have to point your test script at where the API server lives. So if somebody inside your company goes and sets up the API server, ask them for that IP address, put that in the config file, and you can start sending data to the API. With 7 seconds to spare. I think we do have some extra time for questions. Do we? One? Yeah. Who's the lucky one, if there is one?
Okay, we have one person there. There's really the last question to our speaker during the conference Selenium in Berlin 2017. So who would like to be the lucky person? Okay. Ruth, should I give my micro? Okay.
I'll let you guys pick. I don't want to have that on my conscience.
lost you, sorry.
Hi.
Hi.
I have a question about the base timing. Normally, on the local, we can expect the base timing would be this much. But in case of CI tool, if you use Jenkins, or for first time opening the browser itself, it may be different day-to-day life. So how do you, based on some iteration, you calculate and set the base timing for the test? Because we saw that you failed the test since the expected result is not matching with the actual timings.
Right.
So
if I
because
understand,
it's going to, sorry to interrupt, it's going to be more, I think, in case of base timing compared to local, obviously.
Sure. So one of the things we do is the metadata that we send along with the performance data, when we send the data to the API, we also send along things like I'm testing from Sauce Labs right now, or I'm testing from my grid node on the East Coast or in another part of the country, so that later on then when you do your next test, those things are actually taken in by the API, and the API is smart enough to then query Elasticsearch for just the test results that were run with that browser from that location against that environment. And so the baseline matches the test that you're running. Does that make sense?
So basically,
so the next time, when you run locally, there's one field that you send along to the API that's called environment tester. That would be a string called local.
yeah.
And then the next time you run local again, the query that the API does to Elasticsearch to calculate the baseline has a filter in it for environment tester equals local. So it'll only go and grab the local data and determine the baseline of those tests.
Okay, it calculates the baseline, not we are setting.
It calculates the baseline for you.
Okay, that's fine. Thank you.
Make sense?
Yeah.
Okay.
All right.
It was the last question today. Thank you very much, Marcel. Very interesting
Thank you.
presentation. Thank you.